Hey everybody, Matt Wallace bringing you AI every day. I have a packed show for you today, and it hasn't been remotely every day. And part of that is because in my last show, number 19, I showed you my free range GPT plugin, which gave GPTQ control of a Linux box, which was super cool. That project has got some real weird legs, and I had needed a whole show to cover it, and it won't be too fast. Today, I'm going to try to take you through some really cool things about Llama 2, smaller pieces of hardware, GPTQ quantization. Hold on, we're going to go fast. First of all, I have a shell window from a home system. I'm going to go ahead and start this text generation WebUI so you can see this. So text generation UI is a little bit like what Automatic 11 is to Stable Diffusion. Text generation UI is to large language models. And I'm going to click over here real quick. I'm going to load the page. I'm going to go ahead, when this loads, I'm going to jump over to the model. I'm going to pick my model. I've got the Llama2 70B chat. This is the only thing I have yet configured in this, although I have a bunch of other models loaded. EXLLama is a little bit like Llama CPP. It's another pure re-implementation of the model Llama loader in C or C++. This one is a little bit more memory efficient from what I understand, and I'm going to click load. I'm going to take you back to the shell. You'll see it loading. It's going to take just under 8 seconds, I think, to load. And then what I'm going to do is I'm going to show you the video RAM usage on my 2 video cards. So this is my home system that's running this. It is a beefy home system, I'm not going to lie. 2 video cards, there's an RTX 4090 and an RTX 3090. You can see the memory usage here. Card number 1, the 4090, 22.5 gigs. Card number 2, 21 gigs. There's a little bit of memory being used by just the display. So that having been said, put this away for now. We'll might look at this again in a minute. I'm going to come back here. Now, I'm going to go ahead and come over here to parameters. I'm going to choose my presets, and I'm going to make sure that I have auto max token set, although this is 4096. And this is basically the same as some of the other presets. And then I've just changed the top P and typical P. So I can come back to the chat interface, and I'm going to say, tell me about yourself. Now, I can scroll down here, and you can see I actually should have done this. I should have been using this chat prompt. I don't think it's going to make any difference for tell me about yourself. And I actually can also do things like change the style a little bit. I'm partial to this one myself because code looks good in it. And the next thing we'll tell it is, please write me Python code that prints prime numbers from 1 to 1 billion efficiently. It'll normally probably use Civ-Veracity implementation here. Let's talk for a second about what this means. This is the 70 billion parameter Llama model. 70 billion parameters normally would be 16-bit floating point numbers, so 2 bytes per parameter. So think roughly 70 billion times 2 is 140 billion, so 140 gigabytes of VRAM, maybe a little more. The thing is, this GPTQ version is quantized down to 4 bits per parameter, which basically means they are taking the full floating point number and they're shrinking it. But GPTQ, this new type of quantization, there's a paper published last year. I'm going to flash this up on the screen. The performance of quantization from the kind of quote unquote old way of doing the quantization to this way, this GPTQ version, is night and day. When you get down to 4 bits, the old version of quantization basically ruined the model. And you can see here these perplexity scores. Lower perplexity is better. And so when you see this spike way up, this number go way up, it essentially means the model is now getting really confused about what token it should generate next, which means its performance in a lot of use cases will be much worse. Instead, what we see with the GPTQ quantization at 4 bits is that it's staying very close to the perplexity of the original model. And you see this not just with perplexity, which is a sort of measurement about how much uncertainty the model has about which token will come next, but you also see it in performance tests, right? So if you're doing something like a human eval for code or things like that, you see this same sort of performance degradation with the old method, but GPTQ is very close. Like it's borderline indistinguishable. That's mind-blowing, right? Because instead of using 140 gigabytes plus of VRAM, I'm putting it on my home system, just using a little over 40 gigabytes with all the buffers and things attached. And that leads to this generation where, despite this being the 70 billion parameter model only running on my little home video cards, I'm still getting, as you can see here, almost 14 tokens a second writing this Python code. That's really powerful. I think it really plays powerfully into the enterprise use cases as well, because of course, GPT-3.5, GPT-4, those are the kind of landmark, the tentpole releases that have really kicked off this interest in LLMs, and they're really changing a lot of the use cases and inspiring people to go out and build applications on this. But, that's really expensive hardware. If you want to go and run 160 gigabytes of VRAM on AWS so you can fit in the full 70 billion parameter model at that full 16-bit width, you're talking about something on the order of probably $16 an hour to run those instances. Even one of the really cutthroat secondary providers, it's probably almost $3 an hour, which if you take $2.50 to $3 an hour on the sort of cutthroat GPU hosting providers, we're still talking about something that's $1,700, $1,800, as much as low $2,000 a month just to run the GPUs for one inference endpoint. And it's not that my home system is super inexpensive, but that's like less than 2 months of cloud GPU usage, and you could probably clone my system. Certainly from the perspective of doing this, like mine is probably overpowered for the LLM use case in particular in various ways. If you think about the 7 billion parameter version of Llama2, at 4 bits, that only needs about a little over 3.5 gigabytes of RAM. And guess what? An iPhone has 6 gigabytes of RAM nowadays, and it has the neural engine processor, which means you could actually be running the lower end version of a Llama 2 model directly on your iPhone and having it do things with you. Move over Siri. So really powerful in terms of the sort of arc of enterprise use cases, because there's a ton of tire kicking that is definitely going on from the perspective of using GPT-3.5 Turbo and GPT-4 to build use cases. But then people are motivated, I think, to look at Llama 2, which is really the king of open source models now, because they want cheaper inference, because this is much less RAM, certainly much less than paying OpenAI per API call. They want to keep their data private, even if OpenAI explicitly states that they do not train their models on data that's sent to the API. They don't keep the data past 30 days, etc. Some people are still very nervous about that. Sometimes even if they're using the private endpoints. And that's another thing, is Azure obviously has a private endpoint where you can send the data not over the internet, but into a version of that model privately. They're also touting the privacy of that solution. But then from a fine-tuning perspective as well, although this could be a show of its own, literally yesterday, they released GPT-3.5 Turbo fine-tuning. It's fascinating too, because OpenAI commented that GPT-3.5 Turbo with fine-tuning for specific use cases can perform as well as GPT-4, but be much faster. Now it's expensive though too. The fine-tuned version, once you do the fine-tuning, which itself has a cost, but for any real use case, it's not going to be super significant. But doing the inference on it is actually 8 times as expensive per token as it is in the base 3.5 Turbo model, which still is less than half the cost of GPT-4, which I think is about 30x, but it's still substantial delta there. So you think about something like a Llama 2, you can train it, you can fine-tune it. You're already seeing a bunch of community and open source driven fine-tunings appear. So it's starting to become well known how to train it. There's notebooks available for it. And then you look at the ability to run it on what is essentially low-end hardware. We covered a ton today, right? So you've seen text generation, WebUI. We talked about GPTQ and how the performance is so close to the full 16-bit model, even though it's running at 4 bits, which lets me put it in consumer cards, which you just saw at work here on a home system. And then we talked through how that fits in the enterprise use cases. So this was a whirlwind. Please reach out to me with any questions. I'm really interested in what people think about all the concepts we're covering here, which I like to keep this show short. But on the other hand, this is pretty dense. There's a whole ton to know and think about. And I'm happy to go into it in more detail. So tell me what you think. And follow me, like, and subscribe this. Tune in some more, and we'll talk to you next time.